very big and very small numbers. Standard numbers are not suitable to use when expressing normal values if we don't have any strong reason for this. For example, it is not necessary to write 38 as 3.8 times 10 to the power of 1 or 0.41, as 4.1 times 10 to the power of -1 unless this is explicitly demanded. We normally use the standard form for convenience, to express either very large or very small numbers. For example, instead of saying, the green light has a frequency of about 545 trillion Hz, we say, the frequency of green light is about 5.45 times 10 to the power of 14 Hz. This saves us the time and effort to write numbers with many zeros at the end. The same thing can be said for very small numbers as well. Thus, instead of saying, the diameter of a hydrogen atom is 0.106 nm, nm means nanometer, which is equal to 1 billionth of 1 meter, we say, the diameter of a hydrogen atom is 1.02 times 10 to the power of -10 m. This saves us a lot of previous time in units conversions and other annoying actions deriving from the use of such numbers. The general rules applied when converting very small or very large ordinary numbers into standard form are as follows. 1. If a whole number a equals a, b, c, d, e, f, n is very big, the decimal point shifts n-1 positions due left and the index of 10 also becomes n-1, where n is the number of digits of the original number. Hence, the number becomes a equals a, b, c, d, e, f, n, times 10 to the power of n-1. For example, in the number a equals 327,416, we have n equals 6. Thus, we obtain for the standard form of this number, a equals 3.27416 times 10 to the power of 5. 2. If a big number contains a decimal part, if it is not whole therefore, the previous rule is applied by starting from the decimal point. However, the digits after the decimal point are all written when the number is converted into the standard form. For example, if a equals 30,681.27 is converted to standard form, n equals 5, it becomes a equals 3.068127 times 10 to the power of 4. 3. If a very small decimal number b equals 0.0000 a, b, c, d needs to be converted into standard form, we shift the decimal point from its actual position to after the first non-zero digit, here after a. As for the index, we count how many positions the decimal point has shifted and this number is written as a negative index. In our case, we have a shift by 5 positions due right, so b equals a, b, c, d, times 10 to the power of -5. Example. The wavelength of yellow light is 580 nm. Given that the speed of light is 300,000 km per second, calculate the frequency of yellow light in Hertz. The equation of light waves is shown in the following on screen, where speed is measured in meters per second. Solution. First, we write all values in standard form. Thus, since nanometer is 1 billionth of meter or 10 to the power of -9 meter, and 1 kilometer equals 1000 meters equals 103 meters, we have the following shown on screen. Thus, we have the following shown on screen. That is all for lesson 7.3.5. To continue this tutorial, please watch 7.3.6. Powers of numbers written in the standard form. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.